Hello, good morning. I'm going to continue learning Python. Heavenly Father, you are the keeper of every heartbeat and every hour, crafting rest in the chaos and purpose in the fatigue. Your Holy Spirit sustains us when our bodies falter and our minds wander. I praise you for your mercy that never sleeps and your strength that carries us through the night. Lord, I confess I've been running on caffeine and too little sleep, trading your gift of rest for false energy. Forgive me for leaning on caffeine instead of your peace, and for letting shame speak louder than grace. Thank you, Father, for bringing me this far in life through mental battles, setbacks, and all. Thank you for the chance to continue learning Python um, on stream this morning, one step at a time. Holy Spirit, give me clarity and calmness as I continue to learn to write some Python. Help me embrace the learning curve without panic or perfectionism. Please lift up Paul from church as he faces jury duty. Let the attorneys find a reason to excuse him so that he can return to his students sooner than later. Also, please keep Veronica safe as she flies out to work this week. Grant her smooth travels, good health, and moments of joy. May this stream be a space for honesty, healing, and hope for anyone watching. In Jesus' name, amen. All right, so this is where I left off. Strings are not mutable, and comments could be created with hashtags. Awesome. Oh, I just learned that. If s equals hello, what is the output of s1? That would be the second letter, so E. If s equals Sammy, what is the output of um starting from 2? That's 0, 1, 2, so M, and all the way to the last, so MMY.
Welcome back, everyone. Let's now discuss string formatting for printing. Often, you're going to want to be able to inject a variable into your string for printing. So we already learned about concatenation. For example, you may have a variable called myname equal to Jose, and you want to print the phrase, hello, Jose. So what you may end up doing is say print, and then inside of that print function you say hello, and concatenate it with the myname variable. Now there's actually multiple ways to format strings for printing variables in them, so you don't have to constantly be using this concatenation or plus sign. And this in general is known as string interpolation, which is basically just a really fancy way of saying stick a variable into a string. So we're going to explore two methods for doing this. One is the .format method, and the other one is the fstrings method, which stands for formatted string literals. And this is a newer method for some newer versions of Python 3. I personally prefer the .format method, but let's go ahead and show you both of them, and you can decide which is more your style. Let's get started. Okay, let's begin by discussing the .format method. And the basic syntax for this is you're going to have your string defined, and then inside of your string, you're going to have special curly braces as placeholders for the variables you're going to insert. And then right after the string, you call .format, and then inside of this, you're going to call the strings or variables that you want to insert into your string. Let's walk through lots of examples here. We're going to start with the most basic example, which is just saying this is a string, going to set open and close curly braces there, and right after the string, we're going to call .format. So notice how the dot is touching the string there, and then whatever string you want to insert. So to make it really obvious, I'm going to go put in all caps inserted. Run this, and now I see this is a string inserted. So what the .format method has done is it's grabbed this string and inserted it where it saw those curly braces. So there's several advantages here, and we're going to go through all of them. One advantage is that strings can actually be inserted by index position. Let's imagine that we want to insert many things. We're going to say the curly braces, curly braces, curly braces, then say dot format, and say the fox, brown, quick. Now what happens is basically dot format is going to insert these strings in the same order you supplied them and into these curly braces. So right now we have the fox brown quick. What would be nice is if we actually have this make grammatical sense, which is going to be the quick brown fox. What we can do is based off the index position inside of this format call, I can supply those numbers in the order I want. So the very first word I want is actually quick. So this is at index position 2 because it's 0, 1, 2. So I'm going to say, okay, 2 goes first here. And then the next word I want is going to be brown. So that's at position 1, so 0, 1. And then the first word, fox, at index 0 here, is going to be the last one I want. And then when I run this, I get back the quick brown fox. What's also really nice is I can actually repeat these. So if I wanted to say the fox, 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 I could just say the 0, 0, 0 here, run this, and now I have the fox, fox, fox. So I can play around with this in case I ever want to work based off of index position. Now what's also nice is that not only can I call things off the index position, I can also assign them keywords and then just call the keywords. Because here, as I'm working with this, there's no real indication that 0 is fox. Instead, I have to look over here and say, okay, what was the first word? What I can do is assign them keywords. So let's do this. We're going to say the curly braces, curly braces, curly braces, say dot format, and then inside of the dot format call, I'm going to say f is equal to the string fox. So you can kind of think of this as a variable assignment. And then we'll say b is equal to brown. And we'll say q is equal to quick. And then I can use these variable names here, f, b, and q, to insert them. So it's basically using these keywords as variable names here and inserting them that way. So inside of this, I'm going to say the q, b, f. And then when I run this, I get back the quick brown fox. And this is even nicer than previously because it's a little more readable to someone using it like, oh, okay, Q stands for quick, instead of having to look back and ask yourself, okay, well, what was index position 2? And then coming over here to format. So this is able to use these keywords, and I actually really prefer it this way myself. And what's also really nice about this, if again, for some reason you wanted to say the fox, 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 you could just type in F here into each of these braces, and you would get back the fox, fox, fox. So again, using keywords, you can use repetition easily. Okay, to finish off our discussion of the dot format method, I want to briefly talk about float formatting with the dot format method. And basically, this allows you to adjust the width and precision of your floating point number. Let's start with an example. We're going to say result is equal to 100 divided by 777. So as you may expect, this result is a number with a ton of decimal points after it. What we can do is we can actually, when we're printing this out, change the level of precision we want and even change the width of the number itself. So we're going to start off by saying print. The result was, and then open and close curly braces, say dot format, and then here we'll say result. Run this, and we see the result was, and it's basically this kind of large precision number. What I can also do is say r is equal to result, and then pass in an r inside these curly braces, and I get back the same result. So the way the formatting works for float formatting, as far as the dot format method, is you pass in the value that you're referring to. So in that case, it's R here. That's the actual value name. Then you write a colon, and then you write in the width value you want, dot, and then the precision value you want, and then an F. And often what you're really going to care about is the actual precision. The width just allows you to kind of add in some white space if you have a really large width value. So let's do the following. We're going to say value, so that's R colon. We're going to set our width just equal to 1, then a dot, and then the level of precision we want. So this is mainly what you're going to be playing around with, this precision value. Let's imagine I only want 3 places past the decimal point. So I want 1, 2, and then 9, because 8's going to be rounded up to 9 due to the 7 right next to it. Then I would say 1.3 F. I run this, and I get back 0.129. Now, if I play around with this width value and make it really large, what ends up happening is you end up adding white space. And the reason for that is because the width basically describes how long or how wide you want this entire string number to be. That's not terribly useful because you end up writing a ton of white space, but there may be certain situations where you kind of want to edit that. So it is available to you here, but often what you're going to be playing around with is really the precision here. So we can make this 5, and here we can see now we're taking up less of the total width because with white space, because we have more numbers past the decimal point. And you can just generally keep it as 1, but let's go ahead and show you another example. We're going to say result is equal to, let's say 104.12345. Run that, and we can see here that even with 1 on the other side of the decimal point, that's essentially just the same thing, and we can edit around and play with this floating point value. Okay, so that's float formatting with the dot format method. Again, it's the value, your width, and really your precision followed by F. And you can check out the notebook for a lot more examples on this. Finally, we're
Why doesn't it change at 7? Oh, right. Because it probably counts this decimal. All right, cool.
we're going to talk about is F strings, and these are formatted string literals. These were introduced in Python 3.6, so they're still very new, and they offer several benefits over this older .format method. I generally prefer the .format method, but a lot of people prefer this string literal method, especially if they're coming in from other languages. And what it allows you to do is basically skip this step of using .format and instead write result, or whatever variable name you want, directly inside the string. So the way we do that is the following method. I'm going to create a couple new cells here. I'm going to say name is equal to Jose, run that, and then typically what I would have to do is say, hello, his name is, and then I would say .format name. I run this and it says, hello, his name is Jose. What you can do is replace the .format call by just typing an F in front of the string here, and then you can pass in name directly into the typing an F, replace the .format call by just typing an F in front of the string here, and then you can pass in name directly into the string itself. And if you run this, you get back the same result. So this is called F strings, or formatted string literals, and this is new with Python 3.6. And
What? It has to be F. It has to be F.
A lot of people have been requesting this feature for a long time because it's quite common in other languages. Again, because I'm a little more old school, I got really used to this format method, which is why I like it so much. But if you're coming in from other languages, I would definitely suggest you check out the F strings. A lot of people think it's a huge improvement over the previous method, and you can see why. It's actually really convenient to just be able to write that variable name directly inside these curly braces.
When did Python 3.6 come out? Ooh, okay. So,
And this works with multiple variables. So let's say name is Sam, age is 3. What we can do is say print f to let Python know it's a f string. We'll say in curly braces, name
uh,
is in curly braces age, years old. And if we run this, we see Sam is 3 years old. So this is a really nice way to very quickly do string interpolation, which is just injecting these variables into the string itself. Okay, those are the very basics of string formatting. We have a lot more examples in the notebook in case you're interested. And we also have examples of some older string formatting methods that technically still work in Python 3, but I would really recommend that you either use the dot format method, or if you like this new fstring method, use that as well. I'm going to briefly just show you what the notebook looks like for this lecture. So you can see here we have a ton of string formatting examples for you, formatting with placeholders, which is something we didn't talk about this video lecture because it's quite an older method and I wouldn't really suggest you use it. But you can also see how we can use precision and padding for floating point numbers. We also have a lot more examples with the dot format method, inserting objects by index position, reusing them. We also have alignments, precision. So all this stuff, a lot of this stuff we're not really going to use throughout the course, but it is available to you in the notebook in case you want to dive really deep into this topic. So we have lots of examples for you there. Okay. Again, all you really need to know about string formatting for this course is that you can use fstring literals to inject and interpolate strings this way, or you can use the dot format method to inject variables that way. Okay, hope that was useful to you. We'll see you in the next lecture.
I guess the question is, do I need to learn Python 2 um in this boot camp? Write an expression using any of the string formatting methods we have learned except F strings to return the phrase Python rules. For example, these phrases both return I like apples. Your solution should be entered on one line. You cannot use variable names, only the strings themselves. Uh, oh, spelled it wrong. Awesome.
Welcome back, everyone. Now let's begin discussing lists in Python. Lists are ordered sequences that can hold a variety of object types, and they use square brackets and commas to separate the objects in the list. For example, here we can see a list of numbers 1, 2, 3, 4, 5. And lists, just like strings, support indexing and slicing. And lists can also be nested and have a variety of useful methods that can be called off of them. Let's explore all these concepts in a Jupyter Notebook. Let's begin by defining a variable called myList, and we'll set it equal to the numbers 1, 2, 3. So here we can see that a list is defined by these square brackets, and then we have every object type separated by a comma. We just created a list of integers, but we could have also created a list of mixed object types. So the first one could have been a string, the second one could have been a number or a floating point, and this list has no problem. So we can see Python lists are very flexible in the data types they can hold. And if we ever want to check the length of a list, just like we could check the length of a string, we just use the len function that's built into Python and then pass in my list, and it returns back how many elements or items are in that list. So here we have 3 items, string 123.2. Now, just like a string, because a list is an ordered sequence of elements, we can use indexing and slicing. And this works just like a string. So let's show you what I mean by that. I'll say my list is equal to, let's say 1, 2, 3, run that. And then if I wanted to grab the element at index 0, so that's the very first element, I would just say my list 0, run that, and I get back 1. And if I wanted to grab everything starting at index 1 all the way to the end, well, it's just like string indexing and string slicing. I would say, hey, start at index 1, colon, go all the way to the end, and then we have 2 and 3. So this slicing and indexing works just like a string, and you can also concatenate lists together. So let's see this right here. I have my list right now, which is 1, 2, 3. I'm going to create another list, which is equal to, let's say 4, 5. And I can say my list plus another list, and it will concatenate to a new list, 1, 2, 3, 4, 5. Notice here, I'm not actually saving this result, So if I were to call back my list or another list, I can use tab autocomplete here. I still have those two separate lists. If I actually want to save this, I need to assign it to something. So we can say new list is equal to my list plus another list. And then if I check out new list, now it's 1, 2, 3, 4, 5. Okay, so those are the basics of lists. So notice right here we have the indexing, slicing, and concatenation. That should feel pretty similar to a string, except or another list. I can use tab autocomplete here. I still have those two separate lists. If I actually want to save this, I need to assign it to something. So we can say new list is equal to my list plus another list. And then if I check out new list, now it's 1, 2, 3, 4, 5. Okay, so those are the basics of lists. So notice right here we have the indexing, slicing, and concatenation. Should feel pretty similar to a string, except what's different than a string here is that we can actually mutate or change around the list. Remember back when we were trying to change letters around in a string, it wouldn't let us. A list has no problem in that manner. So if I check out my new list, it's 1, 2, 3, 4, 5. Let's go ahead and change one of these elements. Let's change 1 to be in all caps. What I could do is say new list at position 0 is now equal to 1 in all caps. Now let's make it really obvious that we're changing it. So I'm going to say 1 all caps. And now if I take a look at my new list, I have 1 all caps, 2, 3, 4, 5. So that's a way you can actually mutate or change the elements that are already in a list. And that's something that differentiates it from a string, besides the fact that it's also holding different element types in braces and commas. So again, strings, you can change them and affect elements inside of them. Another common operation that you may want to perform is to add an element to the very end of a list. And the way we can do that is we say new list dot and hit tab here, and you should see all the various methods that are available to you in a list. The one we're going to show here is the append method. An append allows you to append a new item to the end of a list. So we'll say append 6. And after running this, what we're going to see is that if I check out my new list, I have 1 all caps, 2, 3, 4, 5, and I have 6 now. So notice how append does actually affect the list, and we call this affecting it in place because it permanently changes that new list to have an element at the end of this. So this is known as append, and again, it allows you to place any item at the end of a list. Let's try it one more time. We'll say new list, append, let's say 7, run that, and let's check our new list, and I can see 1 all caps, 2, 3, 4, 5, 6, and then 7. Just because I'm very zoomed in here, it's kind of cutting it off, but if you were to zoom out, you'd start seeing it in a more normal fashion. All right, so we know how to add things onto a list. Let's talk about removing items from a list. To do that, we can use the pop method. So pop is actually going to pop off an item from the end of a list. Let's show you what we mean by that. We're going to say new list dot pop, open and close parentheses. Remember, for a lot of these method calls, if you don't have parentheses there and you just run them, it's going to report back, hey, that's the pop function inside of this new list object. If you actually want to call it, then you need open and close parentheses. And later on, we'll discuss the differences between methods and functions. You've probably heard me use those terms a little bit interchangeably right now. We'll go into a lot more detail about them later on. But right now, we saw that we said new list.pop, and it's popped off the 7, and it's actually returned it as well. And if we take a look at what new list is now, it no longer has the string 7 in it. Now it just goes up to the string 6. So let's actually save the result of a pop. So we can say popped item is equal to new list, and I'm going to say dot pop. And when I run this, what's going to happen is this popped item is now the item that was at the end of that list. So I can copy and paste this, popped item, and now I have 6 saved as the pop item, and it's no longer as part of my list. Now, a common question that arises here is, hey, I don't want to remove something from the end of the list. I want to remove it at a specific index. For instance, I want to remove the one all caps at index 0. Well, it's actually no problem. You can pass in an index position into the pop. We can say new list dot pop and then just pass in the index position of what you want to remove. We can see here that one all caps is at index position 0. So let's pass in 0 there, run it, and we can see that we've popped off one all caps. And if we see new list now, we have 2, 3, 4, 5. So again, pop basically removes items from the list at whatever index location you provide. By default, the index location is -1, the very end of a list. So reverse indexing also works with a list, just like it worked with a string. A few more methods that I want to discuss besides pop and append, which are going to be really common methods you're using, is sort and reverse. So to do this, I'm going to create a new list. Let's zoom in here. Or I'll redefine new list. And I'm going to redefine new list to be a couple of letters here, but we're going to have them sorted out of alphabetical order. There we go. And we'll also make a numbers list. So we'll say num list is equal to, and let's make this just a bunch of numbers out of order as well. Okay, so we have two lists. If we ever want to sort these lists, what we can do is call the sort method off of them. We can say new list, sort, and you can use tab autocomplete to do this, open and close parentheses, and this is actually kind of a special in-place method because it doesn't actually return anything. Instead, what it's doing is it's going to sort new list in place, meaning that it doesn't return anything. Instead, when you call back new list again, it's now sorted in alphabetical order, A, B, C, E, X. And that's an important distinction to make because a lot of times beginners will do something like this. They'll say, oh, my sorted list is equal to new list.sort. But what's going to happen here is because new list.sort occurs in place, it doesn't actually return anything for you to assign. So when you call my sorted list, you get back nothing or none. And you can actually check the type of this, and it's going to say that it's a none type. And what none type is the type for a none object. So there's actually a special object in Python called none. Notice the capital N there. And this is just something you can use to indicate no value. And a lot of times people hold it as a placeholder, but really what it is, it's the return value of a function or a method that doesn't actually return anything. So it's a common default return value for functions that maybe search for something and may or may not find it, for example. So that's an important distinction to note here, that when you're using this .sort method, it's actually occurring in place, so you're not going to be able to reassign the result to something else. Instead, if you did want to do that, what you'd have to do is say new list .sort and then say my sorted list is equal to new list, and then when you run that, you can have my sorted list, and using tab autocomplete there, and you'd get back your sorted list. So let's try that num list again.
But then you can just use this.
So right now num list is unsorted.
Wait, what? Oh, that's different.
So right now num list is unsorted. If I call the sort method off of it, and I check num list again, now it's sorted. All right, let's also discuss the reverse method off a list. As you may have expected, it's going to reverse everything in your list. So it's just reverse, open close parentheses, run that, and it's also in place, meaning it doesn't return anything. And when you call your reverse version of your list, now you have 8, 4, 3, 2, 1. All right, that's really the basics of lists. And the most important methods to understand are the append method and the pop method, as well as the sort and reverse method. And just like strings, we're able to perform indexing and slicing. So if we come back up here, we're able to say indexing as well as slice notation like up here. So that works just like you would expect it to work as it did in strings. The only thing to note here is, unlike strings, we're able to do reassignments like we did up here with a list. Okay, that's the basics of a list. Coming up next, we're going to discuss dictionaries. I'll see you there.
All right. Create a list that contains at least one string, one integer, and one float. Like, literally, that's the answer, right? It is taking a minute. Awesome. How do I index a nested list? For example, if I want to grab 2 from, oh, I guess it would be, you'd have 2 brackets. So this is index 0, 1, 2, so that's why that's 2. And then if you want to grab the second item, it'd be 1. So what it would return is 2. 2 would pop. This can have multiple object types. Let's see. It would be BC.
Welcome back, everybody. Now it's time to talk about dictionaries. Dictionaries are unordered mappings for storing objects. Previously, we saw how to store objects in an ordered sequence using a list. But now, dictionaries will allow us to store objects using what's known as a key-value pairing instead. And this key-value pair allows users to quickly grab objects without needing to know an exact index location. Instead, you just call the key and it returns the value associated with that key. And the dictionary syntax uses curly braces and colons to signify the relationships between a key and their associated values. So here we can see the curly braces, and then we have the string key, so key 1, then colon, and then whatever value is associated with that. In this case, we just have a string called value 1, and then we have a comma for the next key value pair. Now the question always arises, when do we choose a list, and when do we choose a dictionary? Well, dictionaries have objects retrieved by a key name, and dictionaries are unordered and cannot be sorted. So a good time to use a dictionary would be when you want to quickly retrieve a value without needing to know its exact index location. Now that's a really nice feature of a dictionary, the fact that you don't need to know where something is in the actual dictionary to call it, you just need to know the key value pair. However, that comes with the con of not being able to sort a dictionary. Because a dictionary has a key value mapping, it means that it's going to insert new key value pairs wherever it deems most efficiently. Lists, on the other hand, can retrieve objects based off locations. So that allows the actual list to be indexed, sliced, and then sorted. So you kind of lose that functionality when using a dictionary. So you're basically trading off ease of calling and grabbing something from a dictionary very quickly with a key value pair, and you're losing the ability to sort things or have an index location off of them. Okay, let's explore these concepts a little closer by jumping to a Jupyter notebook. Let's begin by showing you how you can construct a dictionary. We'll start by saying, or create an object, my dictionary, and then we'll have curly braces, and we'll define a key. So keys should be string, and you can call them whatever we want. So we have key 1, and then we have some associated value with that key. For now, we'll stick with basic strings. Then we have a comma, and you can insert a new key value pair. So a colon, and then another value for that. Okay, so we have our dictionary here. And then if we call it back, we'll end up getting the entire dictionary. But really what we want to do is grab values from this dictionary. So instead of using index locations, we still use the same square brackets, but now to get a value back, we just pass in the key that's associated with that value. So we can say in my dictionary, pass in key 1, and we get back that value itself. So a good example of a use case for a dictionary may be something like prices in a store. So we can say I have a dictionary called prices, and we can even call it price lookup. So we have this prices lookup dictionary, and we can have different items in the dictionary, such as apple, and then their associated price. So we'll say apples are, I don't know, $2.99, maybe per pound, whatever. These are made up prices. We can have oranges. Those can be $1.99, and then we can have, let's say chocolate. Well, let's say milk because it's a little shorter type. We'll say milk, and that's going to have a price of $5.80, and there we go. So then, with my dictionary, and remember this dictionary could be huge, prices lookup, I would just want to know, hey, what's the price of an apple? I'd pass an apple, run it, and it returns back the actual price. And now, without needing to know any sort of index location, I can easily get the prices of any of these objects using the key value pairs. So that's a really good example of why you would need a dictionary instead of something like a list, because here I have two values that I want to associate with each other and quickly look up the value of one given its key. Now it's important to note that dictionaries are actually super flexible in the data types they can hold. I just showed you how they can hold integers or floating point numbers as well as strings, but they can actually hold lists or even other dictionaries. So I'll just show you this as an example. We'll say D is equal to, we could have K1 be equal to a key, and it could have a number associated with 1, 2, 3. Or the other thing I could do is say K2, and I can actually have this have a list associated with it. So I can say 0, 1, 2, and then I can even do another dictionary inside of this dictionary. This is not that common, but it is supported. So we can say inside key, and then have some other number here, 100. So the dictionary itself has no problem dealing with all of this. And if we ever want to grab elements from this, let's imagine I wanted to grab this list 0, 1, 2. Then I just call D, pass in its key, K2 in this case, whoops, it should be a string. Run this and I get back the list. And then if I wanted to grab this number 100, what I could do is say D, find the associated key for that, K3. And when I run that back, I get back this dictionary. So off of this, I can make another key call. So then I could just say inside key, copy that, run that, and then I get back 100. So notice what's happening here. I'm basically stacking
3.
Either index calls or key calls to get back the values I want. So let's imagine that I wanted to grab the number 2 here. What I would need to do is say D K2, which returns back a list, and then I want the item at index 2. So then I could just say 2, and then I grab back 2. And this whole thing can be a little confusing at first, so let me walk through one more example just to make sure this is clear. I will say my dictionary has a key 1, and associated with this key is a list of lowercase letters, A, B, C. I run that, I check my dictionary, key 1, A, B, C, and let's go ahead and try to grab the letter C and make it uppercase, because it's a string. What I could do is, through various steps, do the following. I could say my list is equal to D at key 1, and then if I check my list, I have that, so then I could say letter is equal to my list at index location 2, and then if I check out my letter, I then just say letter, uppercase, and then I have capital C. So notice all the steps here that I did. I first grabbed the key, then I made that into a list, then I did the indexing off that list to grab the letter, and then I said uppercase off that letter. But I can actually do this all in one step because of how flexible Python is. I could say, okay, grab that key, which returns back the list. So then off of this, instead of reassigning it, I can just keep calling what I want. So then I want to index by 2. There I have the letter C. And now that this is a string, I can call dot upper, and there I have uppercase C. So you could do it this way as well, instead of having to do each of these steps. Now you're not going to be doing something like this so often, but you do sometimes leverage the power of dictionaries to be able to hold lists inside of them. Okay, so I just want you to be aware of that you can kind of stack calls like that on a singular object. If we ever want to add new key value pairs to a dictionary, it's pretty straightforward. So let's make a new dictionary here. We're going to say K1 is 100, and we'll say K2 is 200. So here I have my dictionary, K1 and K2. Let's imagine that I wanted to add K3 is 300. All I need to do in that case is say D, assign a new key, so K3, and set that equal to 300. And then when I take a look at the dictionary, I now have K3 300. All right.
Oh,
All right, so we just saw how we could add a new key value pair to the dictionary. We can also use the same method to easily overwrite an existing key value pair. We can say d of k1 and set that equal to some new value. So to make it really obvious, we'll just have a new string there, new value. And then if we call d, we see k1 now has that new value associated with it. Finally, I want to discuss just a few useful dictionary methods, and those are methods to grab all the keys, values, or items off a dictionary. So we have our dictionary right now, K1, K2, K3, new value 200, 300. I'm going to reassign it to be the old one. So let me copy this right here and say D is equal to that version of the dictionary. If I want to see all the keys of a dictionary, I can say D.keys, and that's going to return back all the actual keys. If I want the opposite and I want all the values, all I need to do is say d.values, and that returns back the values. And then if I want the actual pairings together, I can say d.items, open and close parentheses, run those together, and it returns back the pairing. So K1 goes with 100, K2 goes with 200, K3 goes with 300. And these, you'll notice, are actually in parentheses, and that means this is actually a tuple, which we're going to learn about very soon. Okay, that's really the basics of dictionaries. Let's do a very quick overview of what we just used. And then if I want the actual values, all I need to do is say d.values, and that returns back the values. And then if I want actual keys, if I want the opposite and I want all the values, all I need to do is say
oh,
d.values, and that returns back the values. And then if I want the actual pairings together, I can say d.items, open and close parentheses, run those together, and it returns back the pairing. So K1 goes with 100, K2 goes with 200, K3 goes with 300. And these, you'll notice, are actually in parentheses. And that means this is actually a tuple, which we're going to learn about very soon. Okay, that's really the basics of dictionaries. Let's do a very quick overview of what we just learned. Dictionaries, their main syntax is defined by curly braces. You have a string key, colon, and then a value. And Python's really flexible as far as what this value can be. It can be another string, another list, another dictionary, floating point numbers, integers, etc. And then you can have another key value pair, and you just separate these by commas. The keys themselves should always be strings. And then we can easily look things up by just a key lookup. Again, it uses that same bracket notation we saw earlier with indexing, except now instead of passing in an index position, you pass in the key itself. We also saw how we can call nested objects inside a dictionary by just basically piling on these key and method calls. Then after that, we saw how we could call the keys, the values, and the items off a dictionary. All right, that's the basics of dictionaries. We'll dive into more detailed aspects of dictionaries later on. We'll see you at the next lecture.
all right. Create a dictionary where all the keys are strings and all the values are integers. Just write the dictionary on a single line. Don't assign a variable name to the dictionary. Okay. I did it. Do dictionaries keep an order? How do I print the values of the dictionaries in order? They don't have order because it's not a it's not a list. Nice. All right. Is this statement true or false? Dictionaries retain order and are a sequence. That is false. But they are not considered a sequence type like lists or tuples. Given d equals whatever this is, what's the output of k1 index second, so 2. This is statement true or false. Dictionaries are immutable. That's false. All right. Wait, this might be a good stopping point because I need I need a break to absorb all that. So, be back later.